Okay, here's another problem where we have an angle inside that's not just regular theta. So again, all these problems, whenever you have a number inside that's not theta, you need to find the answers off the unit circle and you have to add the k value to it. So you do need k values in this one. Even though we have an interval here, we're still going to need to do that process and get the k value. So let's start that. The first thing you have to do though is you need to isolate the cosine here. So first what I'll do is I'm going to add square root of 2 over to the other side. And so I get cosine 3 theta. 2 cosine 3 theta will equal square root of 2. And then I'm going to divide both sides by 2 and I get cosine of 3 theta is going to equal square root of 2 over 2. Okay, so now that I have square root of 2 over 2, I need to find that value. I'm going to pretend that this is just a regular theta. I want to find that on my cosine column. I'm going to go down the cosine column until I hit root 2 over 2. There it is right here. That gives me a reference angle of 45 degrees. So I know that one of my answers is going to be 45 degrees, and of course I also have to add the 360k to it as well. So that's going to, I have that one. 45 is right here. I need to find the other spot on the unit circle where I get a positive square root of 2 over 2 value. So I have one point up here. The other one's going to be down below here because cosine's positive in the first and fourth quadrant, which means I'm going to have another answer down here at 45. So if I go this direction, I have an answer of 45. If I go down that way, I have 360 minus 45. That's going to be 315 degrees. So that's my other angle here. Okay, so now I have both of those. Remember that you have to set these equal to 3 theta because that's what we have going on inside there. It's not just theta, it's 3 theta. And I need to solve for theta. Okay, so I set both of them equal to 3 theta, and now we want to divide both of these to get the exact solutions, and eventually we'll do that to put in our k values. So here's what we get. We're going to divide this whole equation through by 3. Here's the first one that we get. We get theta is equal to, okay, theta divided by 3 is 3 theta divided by 3 is theta. 45 divided by 3 is 15 degrees. 360 divided by 3 is 120. So here's my first solution. I get 15 degrees plus 120k. Here's the second one. Divide this one through by 3. 3 theta divided by 3 is theta. 315 divided by 3 is 105. And 360 divided by 3 is, again, 120. So these are my two exact, or my two general solutions, I should say, for that. But now what we have to do is we need to find the exact solutions, the ones that are between 0 and 360, and this is where we're going to use our k values. Now, because I have a 3 here inside, that tells me that I have to actually use 3 k values. K equals 0, 1, and 2 are the ones I'm going to be using. So first, I'm going to use, so here's my general ones. I'm going to start with 15 degrees plus 120k, and I want to find the exact solutions that go with that. I need to start my k out at 0, and I'm going to put it directly into this formula. I'm putting a 0 in here for k. So I get, when I do that, theta is equal to 15 degrees plus 120 times 0. That's going to give us our first solution of 15 degrees. Next, I want to make k equal 1. That's 15 degrees plus 120 times 1. You always start k out at 0, and you always go 0, 1, 2, however many, until the angles are no longer between the 0 and 360 that we're looking for. So now we got 15 degrees plus that, so now we're going to get 135 as the next one. Next, we're going to make k equal 2. Theta is equal to 15 degrees. We're putting it again in the same formula. We're just putting in a 2 now for k. And so now I get 120 times 2. That's 240 plus 15 is 255. So that's going to be the solution after that. Now if I put in k equal 3, then what happens is I get 120 times 3 is 360, and I'm over that because now I'm adding 15 degrees to it. So again, the 3 here tells us we're only going to use 3 k values. So those are the first 3 answers. Now we want to do it again with theta equals 105 plus 120k. We're doing it now for this equation. K equals 0 will start out as. You're going to do, for theta, we get theta equals 105 plus 120 times 0. That's 105 degrees. That's another solution that we get by putting in a 0 in for k. Now we do k equal 1. Theta is 105 plus 120 times 1. So now we're adding these together. We have 120 plus 105, and when we add that together, we get 225 we get for that one. That's the second solution. And then we're going to do k equal 2, 105 plus 120 times 2. That's 240 plus 105, 345 we get for that one. So all 6 of these that I have here on the end, these are going to be all my solutions. So this particular problem, I actually have 6 different solutions. So these 3 here and these 3, so when you write your answer out, you have to make sure you include all 6 of those.